So at the beginning, we talked about indefinite integrals and definite integrals, right? So you can have a definite integral with this too. So, for example, I have from 1 to 2 of the natural log of x dx. Do you know an antiderivative of natural log right now? No, you do not, right? You do not. But remember, we said anytime you see actual natural log, you have to do integration by parts, and that is your f of x. So defining characteristics here, as soon as you see natural log starting off in the integral, you have to do integration by parts, and that has to be your f of x part, okay? And you may be saying right now, wait, there aren't two things that I'm multiplying. Right? When you have natural log, it automatically becomes your f of x. Remember how I keep talking to you about how important that differential is? Because you're splitting it up. My differential means the derivative part. This natural log is going for just the f of x. Notation is important. It is important. I can't express that enough. And look at how sweet this is. So the derivative of natural log is 1 over x, right? Dx, of course. The antiderivative, this is like a 1 dx. So that's going to be x. Then you go across here in diagonal. So I now have x natural logs of x, and this is outside of my integral. Put the notation there. I'm going to say it again. When you're looking at this definite integral, you have already taken that x natural log of x outside of the integral. You have to apply the fundamental theorem of calculus to that part also. Don't forget it. Put your notation there. People forget that all the time because they don't write the notation. Put it in there. Minus, now here I'm actually integrating from 1 to 2 of this. Look what's happening. X over x dx. Well, what's that? That's just a 1, right? So the antiderivative of 1, now I don't do the fundamental theorem of calculus here. We do it all at once because it just makes the most sense. So I have x natural log of x minus the antiderivative of 1 is x, and I am taking that from 1 to 2. All right, do your fundamental theorem of calculus all at once, but you still need this notation here. Then, once you do everything, you'll take that fundamental theorem of calculus all at one time. So 2 natural logs of 2 minus 2 minus 1 natural logs of 1 minus 1. You remember? The natural log of 1 is 0. So I'm going to distribute that. I now have 2 natural logs of 2 minus 1, because negative 2 and positive 1 is that 1. And natural log of 2, I don't know exactly what that is. Just leave it. That's fine to have that in your answer. There's nothing wrong with that. Okay? Now, if you're good at memorizing things, I, my friends, am not. Not required to memorize because it's so easy to do it otherwise. But if you want to, you can. There's usually a whole lot more going on around it, so it doesn't pop up enough to have you memorize it. However, if you are good at just seeing things and you know how to memorize, you can take the integral here of natural log of x dx, and that is x natural logs of x minus x plus c. We figured it out up here pretty easily, right? That's what we ended up with whenever we did our integration. That is what it will always end up. if you have natural log of x by itself, right? If you have anything else with it, this will not work. Like if you have a polynomial in front, you can't do it just like this. You're going to have to do your integration by parts and it changes it. Okay, but if it's just straight up natural log 100% by itself, then you can do this, which is why I've never memorized it because that doesn't happen very often. But if that sinks in and does well for you, then do it. The main thing here, if you have a definite integral, put this notation, wait until you finished integrating everything, then do your fundamental theorem of calculus at the end. Definite integral, indefinite integral, the process is the same. All right? Okay, good job. Go rock the socks off some integration by parts. Remember, I cannot do a U sub, and I'm looking at something that's multiplied. Those are our defining characteristics. Okay.